Station 5 asks us to find the measure of this angle right here. And notice that this is a right triangle, which basically just means that we can use one of 3 trig ratios to figure out exactly what this angle is. And that's a key part of this. So the only 2 things that we know are 2 side lengths that correspond with this angle. And one of the side lengths, 9, is opposite the angle. And one of it's next to, or what we call adjacent to, the angle itself, which would be the 21. Now this side length up here, you could argue that it's also next to the angle, which it is. But we wouldn't use the word adjacent for this side length because this would be the hypotenuse, which kind of takes care of the fact that it's not adjacent. So opposite the right angle will always be the hypotenuse. Won't ever be an adjacent side. So we know an opposite side and we know an adjacent side, which helps us figure out which of the 3 trig ratios that we're going to use, because we have sine, we have cosine, and we have tangent, which are the 3 that we're learning today. So we're going to use a mnemonic device, which is called SOHCAHTOA, to help us figure out which one of the 3 we're going to use for this problem. So it's SO, and then KA, and then TOA. And these, right, the S stands for sine, the C for cosine, the T for tangent, and then the letters that follow represent the sides that are going to be used to help figure out which one of the trig ratios that's needed for each problem. So given the fact that we have an opposite and an adjacent, if we took the first letter of opposite, it's O. If we took the first letter of adjacent, it's A. So which one of the 3 we would think we'd probably use? Well, it would be tangent, or the TOA part, because that deals with an opposite and adjacent. Now, if we weren't given 21 and we were given this one, that would change because all of a sudden we wouldn't have the adjacent, we'd have a hypotenuse. But in this case, we have opposite and adjacent, so we're going to use tangent to figure out what that angle is. So tangent of the angle, right, which I'm not sure what this angle is. I'm just going to label the angle as, we'll say x, right? So tangent of x, which is what I'm trying to figure out what it is, will be equal to the side ratio of opposite over adjacent. Opposite over adjacent would be 9 opposite over adjacent, which would be 21. Now at this point it becomes a graphing calculator problem. There's no way to get x by itself without using your graphing calculator. Assuming it's going to want you to approximate the angle. But basically we have tangent of x equals 9 over 21. You can reduce this. It's always a good habit to reduce, but it really wouldn't make a difference on your calculator. But if you reduce both of these things by dividing them each by 3, you'd get 3/7. So it just might be a little bit easier. So we have tangent of x equals 3/7. So now you're kind of left with this tangent, which is the only thing that's getting in the way of you getting x completely by itself. And it's not like tangent's a number. It's more like an operation. So you can't just divide by tangent because it doesn't make any sense. It's not a number or anything like that. So what we can do to both sides, and this is kind of where the algebra part comes in. What we can do to each side to get rid of the tangent would be to take the inverse of both sides. So we're going to do inverse tangent of both sides. So this tan to the -1 power, it doesn't mean necessarily 1 over tangent. It actually just means that we are taking the inverse, right? So we would read this as inverse tangent, not tan to the -1, which will probably bother your teachers down the road if you refer to it that way. But we're going to say inverse tangent of x equals inverse tangent of 3/7. And why did we do that? Well, inverse tangent of tangent, these will like cancel each other out. It's like taking 5 and multiplying it by 1/5. It works that way where it would cancel each other out. So that the only thing left on this side would be x, which is what you're looking for. And what's left on the right side would be inverse tangent of 3/7, which is actually your final answer if it's like a non-calc section or something like that. That's actually a perfect answer the way it is, but it doesn't really give you an idea of what this angle really is as a specific number. So if you took out your calculator, we could figure out what that answer would be. So you want to be in the right mode because you want to spit out the answer probably in degrees at this point. So if we look at our calculator, the third one down, okay, we're already in degree mode. You might want to change it over if yours says radian. But basically what we can do is we see this tangent button, but right over it on our calculator we see tan to the -1. That's our inverse tangent. So we're going to do inverse tangent of 3/7. And right there, that is our value of x. So we get a value that's like 23.2 for rounding to the 10th. 23.2 So the angle is about 23.2 degrees. We don't want to say x because the question didn't give us x. We created that, so the answer is just going to be approximately 23.2 degrees.